So, in the past, I had a previous design like this for. Hold on one second. Have a pause. Something was running in the background. Now, in the past, I had a previous design like this for a computer sustaining electrons. But again, I showed my design for kind of like a railgun system for space to accelerate systems inside, that are launched into space and accelerate them at faster distances. Now, these are magnets. You see the where the magnet track is on the top and on the sides here. And they're bent like that for the magnetic flux field as the space tools come inside and they get launched out. Now, I was thinking maybe a robot arm or something could hold them, and it could be a track that can launch. The track probably can be right here and right here, and the track will hold the space system safely as it gets launched out. It's through the tunnel, and or it could just simply be and the space system just comes in and it centers out already at its accelerated speed, and it just becomes more accelerated, and it won't hit the walls or anything because the magnets would prevent it from getting close. So before it gets in, the other space tools would just connect onto the incoming space tool at its speed, and it would just it would prevent it from hitting the walls of the accelerator. Now, we can do these in a lot of different ways, put them all over space, one like or multiple. My company can make multiple accelerators, and some of them can connect, and it can accelerate the space tools at speeds that we've never even imagined. So they would connect, they would come together, and it becomes longer, and it can reach speeds that like we really couldn't reach with the rocket systems that we have today. It's a more accelerated way. Obviously, I try to extend this to show you an example of them connecting together. Sorry, I'm still trying to move or position this on here. So basically, the other way is it's like, let's say 5 or 6 different robotic satellites that will connect to maybe a robotic rocket or a robotic satellite that's probably trying to get to Saturn or Neptune or Uranus or Jupiter extremely fast. We can get there really fast, or either further distances if we make like a let's say we make 20 of these, and we either launch it fast at the beginning, or we can put like a series, probably 1 or 2, in between like Saturn and Uranus, and after Neptune, and some in between the darkness of space past Neptune, and some by Earth as it's going towards other accelerators. So it have a trajectorized path to go right into the accelerators, and the accelerators will get ready for like the robotic spaceship or a humanoid spaceship to travel to these distances. So for example, it's like another way we can travel to other distances really fast. Like, for example, if we were trying to get to Mars, we could travel there extremely fast without going through the years of trying to travel to Mars, which I have to do today. With this step, we could accelerate, and they would just have to somehow, keep their body from being affected from the G's or the forces of being accelerated at such a fast rate, and they can get there in less than a few months or so, maybe even shorter. Now, why did I think about using an accelerated track system? Well, I was looking at the sun, and I saw the specific frequencies again, and how the magnetic flux set electromagnetic force in different ways, and I was just trying to think about different magnet designs and how the flux would force. I have a lot of designs. This is just one, and again, we could like make them as long as 4 or 5 accelerators long, and we can send things into deep space all the time, so we wouldn't have to worry about a lot of things. You know what I mean? So it's just the beginning of other things that I'm trying to do with my company. It's making these accelerators. We could make them by the moon, and so whenever we get ready to launch things, we can launch from the moon, or we can put things on the things on the moon to do other things. We can get things accelerated to the moon faster too. A little smaller accelerator, so I can make shorter examples to show people how we can get things to the moon extremely fast. But that's just an introduction. So here is the sketch of the accelerators. Like for example, that's Saturn, and here are the individual ones. That's probably in between Earth and a distance to probably, let's say, Jupiter or Mars. In between the distance of getting to Mars, it would just have to go through three different accelerators in between the distance, and it would get there twice as fast, and or probably more accelerators in between the distance. Like since we could launch out like multiple ones at many times, you know what I mean, and or we can have multiple ones come together, and we could move them around in different positions. Now, for example, getting to Mars, we can have a track of probably 10 or a track of 15. We can get to Mars twice as fast. Now, besides the things that it could do besides accelerating, you can also do other things in mid space too, and or research and on gray matter and or bending mass and or matter, attracting different charges of matter towards the accelerator, and doing research on the particles under the molecular formations that can become using the electromagnetic force, and or the currents that can become from the gray matter being highly charged, being ejected from the sun. Those are Now, lastly, you would think, how would we get all those accelerators out, right? We have to get them out some way, but although we can send them out using a rail system and a little bit of fuel, shooting it at least extremely high into the atmosphere, and the fuel would most likely get it the rest of the way out of the atmosphere. Obviously, we see how other smaller systems fly in the atmosphere and or above, away out of Earth's magnetic field or at the edge of Earth's magnetic field. This would just be an introduction to the rail systems and how many we can launch out, and using a small quantity of fuel whenever it gets to the higher edge of the atmosphere. And we can assemble them outside, or if they're we can assemble them outside whenever they go out there, and it would also be other introductions to working with robotics and space. So today on this side, I'm showing um, the accelerator adjusting and positioning itself for the size and or the capacitor of the traveling system to for it to fit for the railing system to work. Obviously, it could expand at many distances, although it can only expand um, at just the right size for the systems to accelerate through. If it expands too far, it might be a little complex. Although the magnets could still make it work. It's pretty cool. But this is just the model. It's not the final model. And again, I had previously showed it together when it's doing research with matter, or gray matter, and other matter charges around the distance in between the planets, where the planets don't go. Obviously, part of it can just go out and expand. All the matter research in between time, between traveling systems, become apparent. What would just be more research on the new phases of gray matter that's released from the sun. just different charges, some more highly charged than others, depending on that celestial event and or the fuel burning and or exchange reaction. But the light interactions that go on with the sun, it's always different. Sometimes it's more bond like, sometimes it's more bond breaking like. Two different charges of reactions along with other fusions of atoms and particles, that's sustained by the light as it's carried along in the gray matter. So the charges and our anti-charges would be what I would be doing research on in the closed system, and I will constantly make discoveries because the sun makes various types of bonds and frequencies with some of the bonds, and that's how we'll get to know more about gray matter and its interaction with dark matter and our dark energy.